So again, with 5.5, everybody should have their formula sheet out. And if you want the unit circle, but have your chapter 5 formula sheet out, we'll cover some of the double angles, half angles. So the double angle formulas are here, and they're going to be on your sheet. If you look at cosine right here in this one, it looks like there are 3 different formulas, but all they're doing is taking the first double angle where it's cosine squared minus sine squared and adding in some Pythagorean identities. So you can switch out the cosine squared for a 1 minus sine squared or the sine squared for a 1 minus cosine squared and simplify it. The tangent double angle is a little bit crazy too. So yesterday the tangent formula was not so nice. Today it's not so nice either. So we're going to work on solving some of these equations. So the first one is 2 times the sine of x plus the sine of 2x is equal to 0. That's a little bit of a review from yesterday. We're not going to be able to isolate it. So is there a way to switch one into the other? So what's another name for sine of 2x? If you look up above in the... I can make it 2 sine x cosine x. So that's the first substitution that we're making. So I did not change this one. And it's still set equal to 0. So why does that help us now? Because the purple term and the red term what? There's a cosine now in each term, so we can factor that out to the front.
Wait, how'd you? Yeah.
You could also factor out a 2 at the same time if you want, so we could actually take a 2 cosine out to the front. That leaves behind 1 plus sine of x.
Wait.
So this basic substitution came from right here.
Oh, okay.
Yeah. Okay. But what that allowed us to do is factor out a 2 cosine. So now we can set each piece equal to 0. So we can take 2 cosine of x, set it equal to 0, and 1 plus sine of x, and set it equal to 0. So the basic question you're going to ask right here, 2 times what gives me 0? Well, 2 times 0. So 1 is cosine equal to 0. And this one would be subtract the 1. 1 is sine negative 1. So 1 is cosine 0 at the top of the unit circle and at the bottom of the unit circle, and 1 is sine negative 1. At the bottom of the unit circle. So really the only 2 answers are 90 and 270, or again you could be using the radians, the exact radians. Alright, so this one, they're telling me that cosine is 5/13. So where is cosine positive? First and fourth. So I put a check mark out here and a check mark there. Cosine is positive 5/13. So 5/13 is positive, so cosine is positive there and there. Where is 3 pi over 2 to 2 pi? Only in the 4th quadrant, right? So I really don't need a checkmark system because they did come out and tell us what quadrant to put the triangle in. So I'm going to draw a triangle in the 4th quadrant. We're calling it theta. Now the cosine is 5/13, so that's the adjacent over the hypotenuse. What is the missing side? So the missing side is 12, and when I put that on the diagram, what do you notice? It's in a down, it's going down, right? So that you have to put the negative in. The Pythagorean theorem won't give you that negative. You have to look at your diagram and put it in. So now we're going to do a double angle for sine. So look at your formulas in the box or the double angle of sine. The double angle is 2 sine of theta cosine of theta. So all you have to do is look at that triangle. Tell me what the sine is. Sine is opposite over hypotenuse. So that will be opposite 12 over 13. Negative 12, thank you. And cosine is adjacent over 13. So if you go to multiply this all out, I would do 2 times 5 is 10 times negative 12 would be negative 120. And 13 times 13 is 169. So that's the sine, double angle for sine. Then, if you think of the whole number as 2 over 1, the 2's multiply the 2, the negative 12, and the 5, 1 times 13 times 13. Whole numbers always go to the numerator. Now, on the cosine, there are 3 different formulas. Probably the easiest is to just do the cosine squared minus sine squared up above. See that? Cosine squared minus sine squared, right? So cosine we already know is 5/13. Square it. Sine, we've already done sine, it's right there. It's negative 12 over 13. Square that. So you end up with 25 over 169 minus 144 over 169. What's 25 minus 144? What's 25 minus 144?
119.
So there's my double angle for sine, there's my double angle for cosine. Alright, now when we get ready to do the tangent, that tangent formula is kind of ugly. And it'd be a lot of work. You should probably try using it one time, but I'm going to show you, instead of doing the formula up above, I'm going to do sine of 2 theta over cosine of 2 theta. Well, what's sine of 2 theta? It's right here. The negative 120 over 169. And what's the cosine of 2 theta? Right here. Negative 119 over 169. So when we do the work, we're dividing by a fraction. So we already have the 2 answers. So now we go negative 120 over 169 times 169 over negative 119. Little chunga there. 120 over 119 would be our final answer. I don't have to use the formula. I have the answers right there. All right, so this is a DIY. You're going to go through the same process that we just went through. Draw your triangle, find the missing side, answer the double angle, and the double angle. And then we'll put the answers up in a second. So, draw your triangle in quadrant 1. It's a 3, 4, 5 triangle. The double angle for sine is to do 2 sine cosine, 3/5, 4/5. Remember, if you need to put the 2 over 1, multiply across the top, 24. Multiply across the bottom, 25. Then when you do a double angle for cosine, they did it a little bit different. Many of you might have gone 4/5 squared minus 3/5 squared, which would be 16/5 minus 16 over 25 and 9 over 25. They're just showing you a different format. There are 3 different cosine formulas if you play around with Pythagorean identities. Many of you did this one, right? Yeah. Just like we did in the lecture. All right. So you get 7 over 25. Now, when you get to the tangent below, what could we do? Put the 24 over 25 over. So again, look what happens when you do a tangent. So if you do the formula the way it is meant to be, you have 2 times the 3/4, so you have to do the tangent of your triangle, and then it's 1 minus the tangent squared, and then, you know, it just gets to be a little bit ugly. You could probably type it all in your calculator if you were careful enough, but you get 24/7. I think it's easier to do this formula like we did in class. You're multiplying by the reciprocal because you divide it by a fraction, or you divide by a fraction, so you multiply by the reciprocal, and you get 24/7 anyway.
24/7.
So those should have been your answers.
That's how often I think last year when I took.
So this is something that looks like a quadratic, except I have a sine and a cosine in the problem. So one of these must be able to change into the other one. I could change sine squared into a 1 minus cosine squared, but I have this 2x term. So when I do that, the sine of 2x is going to cause this problem. So this is the one that I'd like to switch out. So what's another name for the double angle of cosine?
Cosine squared.
1 minus 2 sine squared.
We want to use that one. So find the double angle that is 1 minus 2 cosine squared, 1 minus 2 sine squared of x. That's the substitution we want to make.
Oh, I see.
There are 3 forms for the cosine,
Totally.
and we want that one.
Where?
I did not change this, and I did not change this. So all that stuff's true, I only changed the blue one. Now we would reorganize this. Sine squared goes first. There's a 2 sine of x, so that's minus 2 sine. Well, I can. What's that? Yeah, we should add those together. So, how much is 3 minus 2?
1.
So really I'm only left with sine squared of x, right? Now, I have this 1 and negative 2. So that's minus 1 is equal to 0.
You add one now?
So when you look at this, you would add the 1, square root both sides. What do you have to remember? Plus or minus, and the square root of 1 is 1. So when is sine 1 or negative 1?
270.
90 and 270. The second number of your ordered pair is 90 and 270. So now we're getting into some of the half angles, so make sure you know what box they are on the formula sheet. The half angles. We can do a half angle for the sine, the cosine, or the tangent. Now, a couple of things. One, this plus or minus, I will show you how to determine plus or minus before you start the problem. This is not plus or minus as in we get one positive answer and one negative answer. We will determine whether to use the positive or negative before you start the problem. Then when you do tangents, you do not do both of those formulas. My suggestion is use the one that's the nice denominator. And you'll see what I mean by that. We'd rather have nice numbers on the bottom rather than throwing square roots on the bottom. So if you have a choice, avoid putting square root on the bottom of your denominator. So it's not that each one has 2 answers. They're just these formulas, and we'll pick which one we want to do. All right. Now, the sine of 105. We've already done the sine of 105. We could do what? We did it yesterday. We could do 60 plus 45. You could do 135 minus 30. So you could use your sums or differences. They're asking us to use the half angle formula, so that's what we're going to do. So sine of 105. What you're going to do then is when you look at your formula, the sine of 105 is plus or minus. We're going to determine it right now. What is the sine of 105? What quadrant are you in? We're in quadrant 2, right? Is sine positive or negative in quadrant 2? Positive. Because the sine of 105 is positive, we're going to take this formula right here. Sine of 105. And we're going to do the sine of something over 2, and we're going to do the positive square root. So we've already determined use the positive. What number divided by 2 is 105? Or double 105, and you're getting 210. That's kind of what they're telling you here. So, when you look at the formula, even though you're doing a sine, you're doing 1 minus cosine. So in here you do 1 minus the cosine of 210 all over that 2. But cosine of 210 is on the unit circle. So what is the cosine of 210? It's going to behave like a 30. Yep. And root 3 over 2. So now you have square root 1 minus root 3 over 2. But cosine of 210 was in what quadrant?
Oh.
The second. Or 210, excuse me, is in the third quadrant where cosine's negative. All over 2. So what happens with that double negative? It really is a positive, right? Minus a negative number. Now, yesterday we did some square roots. You have a square root at the top and a square root at the bottom. So technically, what do we have in the bottom? Square root of 2. We're not allowed to leave an answer square root of 2. So we're going to use that trick that we had yesterday. We're going to multiply the top by 2 and the bottom by 2. So now what I'm really looking at is the square root of 2 plus root 3 all over the square root of 4. Because you can separate the 2, square of the numerator, square of the denominator separately. So what happens here?
Becomes a 2.
So that becomes a 2, so we're good. And then the top, there's really nothing we can do to simplify that. So it looks really weird. So let's go back and look on our calculator to make sure we have the right answer. So the sine of 105. It's a positive decimal. That's why we chose instead of the negative, we did the positive square root. Now my answer, this is a little bit tricky to type in. On the top, I have the square root of 2 plus.
It's 2 plus square root of 3. Isn't it?
2 plus
Yeah,
square root.
2 plus square root of 3. That's what I'm typing in. 2 plus. Now I do
Yeah.
another square root of 3. Get out of there, get out of that one, and now that's my numerator. Divided by 2, right?
So it's not this one.
And it spits out the same decimal, so I know my answer is correct. So this one's a cosine formula. So again, determine at the beginning, cosine of 165. What quadrant are you in?
Second.
Quadrant 2. Is cosine positive or negative?
Negative.
So right away we know we're going to do the negative answer. So you go cosine of 165 could also be written as the cosine of what over 2?
330.
330. So when you look at the formula then, we've already determined we're doing the negative square root. This time it's 1 plus the cosine of 330 all over 2. Because it's 1 plus the cosine of u, and your u is set at the 330 now. What is the cosine of 330?
3 over 2, square root of 3 over 2.
Root 3 over 2 all over 2. So when you don't have any positive or negatives to worry about there. So now you have a square root of 2 again on bottom. So use our little trick. Inside the radical here, we're going a 2 over a 2. So I multiply it on the bottom by 2 and distribute to both of these terms. So you end up with negative square root of 2 plus root 3 all over the square root of 4, which simplifies to a negative 2 plus square root of 3 all over 2. Now, on the exam, if it says find the cosine of 165 or the cosine of 105 and it doesn't tell you what formula to use, sometimes the sums and differences type formulas are easier to use, and you can use them if you want. These were half angles, so that's why we did them. So this last one is a verify trig problem. So I'm going to give you a second in your groups. You're going to start it, and I'll kind of walk around and see what you're doing. Let's just determine, though, as a class, which side do you want to start with? Which one seems to be...
Left, right.
Okay, let's all start... Let's all start with this one. So we're going to take our cosecant of theta over 2 cosine of theta and see what you can come up with, and we're going to try to get it to be a cosecant of 2 theta. I'll pause it and then you guys can work on it and then we'll look at it in a second. So, one of the things you might try is turn this all into sines and cosines. Because this is not the double angle on the bottom. So I could go to 1 over sine over 2 cosine. So this creates a complex fraction because you have fractions within a fraction. So if you need to, put this one over 1. So now you're going to have 1 over sine of theta times 1 over 2 cosine of theta. And what do you do when you multiply? You end up with 1 over 2 sine of theta cosine of theta. Well, what's another name for 2 sine of theta cosine of theta?
Oh, that's the sine 2.
That's the same as 1 over sine of 2 theta. Well, what's another name for 1 over sine? Cosecant. So this is cosecant of 2 theta. And that's what we were trying to get to.
Oh, wow.